All right, in this video, I want to talk about how to solve a system of equation using the substitution technique. Now, the most important thing for using substitution is that um, you find the single variable equation that's given to you. Okay, that is by far the most important thing you can do is find the single variable. So if I give you these two equations, y equals 6x minus 11, negative 2x minus 3y equals negative 7. This first one has the single variable. We have a y equals. So what we're going to do with that single variable is wherever we see the single variable in the other equation, in this case, here's y, that 6x minus 11 is going to go in place of y. Okay, so what ends up happening is we get this equation, negative 2x minus 3, right? And then in parentheses now, 6x minus 11, because y is equal to 6x minus 11, so we can substitute those, we can replace those, right? And then we end up with this equation here, right? Now, the first step we need to do is we need to distribute. If I could spell distribute, that would be awesome. All right, there we go. Okay, distribute. So remember, with distribution, we want to make sure every part of the parenthesis gets distributed to. All right, so we have negative 2x. We also have to be mindful of the negative signs in these problems because that is definitely going to be a place where you're going to make an error. So now we have, and I forgot to distribute the first term. There we go. All right, here we go. So we have negative 2x, and it's a minus 18. See, there you go. I made a mistake with the negative sign. And then plus 33 equals negative 7. All right, the next is we're going to combine like terms. All right, so we combine like terms here. We're going to get a negative 20x plus 33 is equal to negative 7. All right, next we're going to move the number terms. Okay, and by doing that, we're going to have to do the opposite of it. So we're going to subtract 33 from both sides, and that's going to give us a negative 20x is equaling to a negative 40. And then at this point, you guys should be able to get x equaling to 2. Now what happens is we need to get the y value. And so we're going to take this x equals 2 and plug it into the single variable equation, right? So we said y is equal to 6x minus 11. And we just said that x is equal to 2. So we do 6 times 2, which is 12, minus 11 will give us 1. And so the final answer of our system of equation would be 2 comma 1. Right? So again, the ideal situation is we have a single variable equation and we plug that in and use our algebra skills to solve. Now, what happens if we have something like this next example where there isn't a single variable easily seen? Well, in this case, one of the equations has a single variable, but we have to use our skills of literal equations in order to solve for it. So what I'm going to do is solve for y using this 3x minus y equals 10 equation. So if I wanted to solve for y, what I'm going to do is add y to the right side and subtract 10 to the left. And so what I'd end up with is 3x minus 10 is equal to y. Now I have my single variable equation, and now we can plug this in to this equation right here. So what we would end up having is 2x plus 4 times 3x minus 10 is equal to 2. Again, where did the 3x minus 10 come from? That's what y is equal to. And so wherever y is, 3x minus 10, that's what it becomes. And then we would follow the same steps. Distribute, combine like terms, move the number term, solve, substitute back in, and so on. So the steps would be the same, but the startup is a little bit different because we have to solve for that initial single variable term. Now, the next example I want to go over is not the greatest for substitution. In fact, there's a better method for it called elimination, which is covered in a different video. What we can use substitution, though, for a problem like this. And what we need to do is to pick one of these equations and solve for a single variable. Now, is there a better equation in this case for a single variable? Not really, because they're both going to give you a fractional term. But say I wanted to solve, this top equation for x, since we've used y so much. Okay, So if I have 2x minus 4y equaling to 5, right, and I want to get x by itself, I'm just going to get rid of the second equation here. And so what we're really doing in this case is we're using our literal equation skills. So I'm going to add 4y to both sides, okay, and I get 2x is equaling to 4y plus 5, okay? And now we're going to divide everything by 2. And in this case, I would divide every term on the right side by 2. And so we get x equaling to 2y plus 5 over 2, or we could use the decimal. It just depends. In this case, I'm not going to solve it. And you can see where the numbers get kind of not nice. I mean, it's not a terrible number, but it's not a nice whole integer number. So now in this case, we could take this x equals equation and plug it into our y, or our x in another equation of that system. All right, so that's the quick overview of it. It seems maybe complicated at first, but it's really, you're trying to identify that single variable equation.